In the previous lesson, we explored some important database concepts at a high level. In this lesson, we'll learn about the principles of database tables. We'll look at the structure of database tables and the different roles that tables can fulfill within a database. Each table in a database consists of a series of rows and columns. For example, here we have a table holding information about the fee earners of a professional services company. In this table, each column contains a different piece of information about the fee earners. In this context, a column is referred to as a field or an attribute. All the data in a particular field must be of a single type. We'll learn more about this in the next lesson. Each row in the table represents an individual fee earner. In a database, a row is referred to as a record or a tuple. If we look at this table, we can see that each fee earner has a unique name, while the other fields contain duplicate values. As a result, we can say that the name field is the primary key for this table. A primary key is a field which uniquely identifies all the records of a table. If we are told the name of a fee earner, we know exactly which record in the table refers to that fee earner. If we were told a fee earner's rank, we would not automatically know which record the rank referred to, as many fee earners have the same rank. Every table in a database should have a primary key. This is not an absolute requirement, but it is best practice. Having a primary key prevents you from identifying or selecting an incorrect row, which could happen if all the fields contain duplicate values. This is especially important when you're joining tables together, which we'll see later on. Sometimes, one of the fields in your table will naturally be a primary key. Other times, you'll need to add a primary key field of your own. For example, if we're working with a large company where multiple employees have the same name, a table like this could include an employee ID field, which could serve as a primary key. There are many different ways of classifying database tables into types. One of the most common involves describing each table as either a fact table or a dimension table. A fact table contains data corresponding to some business process. For example, in a retail company, sales or purchases could typically be described using a fact table. In a fact table, each record represents a single event, and each field represents some aspect of that event. So in a sales table, each row would represent a sales transaction, and each column would represent some aspect of that transaction, such as selling price, the quantity of products sold, and the customer the products were sold to. A dimension table contains data corresponding to objects that are involved in a business. In the retail company, things that could be measured in a dimension table would include products, customers, stores, and so on. Each record in a dimension table represents an individual object, and each field represents some attribute of that object. So in a product table, each row would represent an individual product, while there could be columns for the product's name, its cost, and its selling price. In a typical database, fact tables have a tall and thin layout with a high number of rows and relatively few columns. By contrast, dimension tables tend to have a short and fat layout with fewer rows and more columns. The intuition for this is easy to understand. In our retail company, we would expect each product to be sold many times, so it makes sense that a table containing sales transactions would have many more records than a table containing product details. Also, each of the products would have many associated fields containing various pieces of information about the product, but we wouldn't want to record all those details every time the product is sold. Instead, we would just record the product name and use the product table to identify the rest of the information about the product. As a result, fact tables are likely to have fewer columns than dimension tables. Let's stop the lesson here. In the next lesson, we'll learn more about how data is stored in tables, focusing specifically on the concept of data types.